Okay, so this is the library that we are going to use in our library for the driving the DC motor. So this is a PWM library. You can see that this is the command or the library that we can use. So each of the command here will be details out in this box over here in this table. So what is about the prototype void? This is, you have to go back to your C++, the structure of programming and how to work with the subroutine or any library that you want to create. So this is the function of it. Like for example, this is to initialize the PWM. So it must have the CCP module, which is CCP1 and CCP module 2 that we have. And how to run it is like this, PWM init. So let's try to take this one. So if you can remember back the previous lecture that I have, so there's a slide showing that how you have to do it manually, all these things, how to create this PWM. But by using this library, you just need to run this one line, and that one should be enough. Okay. So let's run this one. So you can see there's a still got red lines over here. Seems like maybe got something wrong. So let's try to build up this one first. Yes, this is a problem. So it's undeclared identifier PWM underscore init in expressions. So even though it's correct, this is correct, right? So now your compiler is trying to search for the library, but it does not find it. So what you can do is you have to go to one Windows over here. Go for here. This is macro E libraries. Go to here, and then there will be a lots of libraries that you can select. So for this type of application PWM, you have to check the box next to it. Then you are done. So the rest is the other libraries that Micro E provides to you. So let's try. You see there's no more line over here, curly lines over here, there's no more. So you can build out this one. So yeah, you successfully built this one. So after you have this initialization of your PWM, then you have to start it by according to this one. This is how to set it. How to start. This is what PWM start is, starts the PWM. So you have to do this one. This is a command. Then you have to start it. Then you are done. You already complete your PWM. Okay, so your PWM is correct already. So right now you have your port B and port C is already have the connections to the driver. Okay, so you have to do this one. So let's try here. You want to turn on the motor. So your motor right now is connected to RB0 and RB1. So let's try to do this one. Port B .F0. I just want to specific on this particular pin as pin port B pin 0 is equivalent to 0. Now you are going to have this one, and then another one is port B .F1 is equivalent to 1. Remember that this is like your H bridge. Another one must be 0 and another one must be 1. So it can rotate your motor. Okay, so after this one is completed, so you have to give the PWM. Okay, hold on, I just need to double confirm on that. Let's see. Okay, correct. So after you have this, then you have to start your PWM here, and then you have to set your input, you have to activate your motor, and then you have to give the duty cycle. So in this help just now, right, for the PWM, you can search again like this one, right? PWM library. Set duty is the one that giving you the value how much your motor will be rotated. So that's why you just take this one first, put here. So the value you can change is inside here. So what does that mean? How to change this value? So what does it say? Okay, the this command is this guy. It will set your PWM duty ratio. Parameter, which is this one, takes value from 0 to 255 only. So means that you can change this value from 0 to 255, where 0 is 0% of your duty cycle, 127 is half of it, and the maximum number can be put is 255 for 100% duty ratio. So means that if you put this one as 255, means that your motor will be rotated up to its full speed. That is the maximum number that you can put inside the PM1 set duty. Okay, other specific values for duty ratio can be calculated as this one, but we don't really care this one. We just want to have this one. Alright, so you're going to set up this one here again. So we are going to put at 255. 255 is the maximum speed. Okay, let's try. Before that, I just want to try to show you guys that if we do not put the PWM, we just put PF0 and 1. Okay, let's try this one first. Is it working or not working? The build is completed, but at this one you have to go and select it. This is the one. Module macro C. This is coding example. This is today, which is this one. This is my project. This should be 20 megahertz. Do not forget it. Then you run it. You remember that this is a 5-volt motor, so just run it. So you can see that this motor is not moving, even though I turn on one of them, high and 0. High and 0 is correct, and there should be an output over here, but it does not work. So let's try to put back again the PWM at your program. So this one set duty cycle. So build again. Okay, stop this one and run it again. So you can see that my CCP pins is 100%, like most of the time is straight. Basically, most of the time is straight. Is a full PWM, and it's moving one of them. So you want to see this one. You want to see the value of the you can find the oscilloscope over here. There's an oscilloscope here. Yeah, this is oscilloscope. You can see, we want to see what is the value coming out from the CC pins. Let's try to have a look over here, and then we run it. So you can see that this is your PWM. So go for DC here and try to figure out, this is not this one, and you have to go for the milliseconds here. So here, so you can see that this is like a full wave, right? After that one period it will go down. So I don't want to use this one. So after one period it will go down like that. So let's try to look at the results on 50%. You can go back to your micro C and change this one to what's the value just now? 255 divided by 2 is 127. Okay, let's say 127. Here you change it to 127. Okay, and then you run it. Build here, and then you can see that. Try again. You can see that the value is not 100% just now, it's half of it. So you can see actually it's actually half, right? So you can see that your motor is half of the speed. So without these CCP pins connected, you cannot run the motor, you cannot rotate the motor with a driver, because it needs to be driven by these two H bridge. Consider H bridge, and this is your input for the PWM. So you can control your PWM accordingly to the set duty command just now. Okay, so let's try another thing. You want to rotate, this is a counterclockwise, so let's rotate this one. You can change the value again here. Instead of this one, you are going to change it on to 1 to and 0. This is like H bridge, remember that? So build again, and then you can see the result is like this. No. Just now it's counterclockwise, now it's clockwise. Okay, the value you can change it. Let's try to go for 0. Change this one to 0, or maybe I make it, don't go for 0 because it will work. So I just go for 10. So go back to run this one. So you can see that your PWM is very small. The duty cycle is very small. So the motor run rotation is very slow compared to the one. So it means that you are giving basically a very low voltage accordingly to this PWM, because the area under this graph is small. Okay, so this is for the 5 volt. Let's try again. If the motor is 12 volt, it can run or not. Let me try this one to 5 volt nominal without battery outside. So let's change this one to full speed again, which is 255, right? And then compile this one again, and then run. It still can run, so it means it still can consider this one. So by right, on the hardware, this is simulation. On the hardware, you must put the B1 here to here. For example, you must have this B1 as 12 volt, to be connected here and to the ground. So this is the configurations, correct connections by using PIC and the driver. So your task, I'm going to give you assign a task. Okay, assign a task for you guys. You are going to write a code, micro C code, to run 2 motors by using another input output from here, and you can select which port that you want to use to turn on this driver and drive another motor. So the assignment will be assigned after this. I'm going to let you guys know what you need to do. Okay, so this is the one. This is the concept of the running the motor, how to activate, how to control a DC motor. Okay, I think that's all for today, because this is very basic command, but you need to understand how to use it. So that's all for today. Thanks for the tutorial, and I do hope that you can complete the assignment then. Thank you very much.